Since you've started developing a stronger foundation in trig identities, we can tackle more difficult puzzles. Just in case, at the top right-hand corner, I've put two clouds that have the trig identities we've already proven. So in any case, if we wanted to, we could always use those in the proofs. Let's start off with the left hand and the right hand side and put them into a table. Okay, so here's the left hand side and then the right hand side. Taking a step back, I'm looking at the right hand side thinking, well, that looks very easy. It's really simple. There's nothing really we can do to it. In which case, maybe I'll look at the left hand side and I'll start working on that. So equal sign. And then before I start writing anything, I'm noticing that this sine squared x, it doesn't really appear in the other side anymore. On the right hand side, it's all coses. So what I'd love to be able to do is change the sine squared x into a cos of some sort. Looking into the clouds, I notice that the Pythagorean identity allows us to change sine squared into 1 minus cos squared. So that's what I'm going to do in order to have all of the left-hand side coses. Okay, so that's basically information from the first tutorial, but what sets this question different than the ones that we did in the first tutorial? You're starting to get things like difference of squares. Now we have to add in this new element, which is factoring. Okay, so notice that your a here is 1. So the square root of that 1 is just the a, not a squared. And then you have cos squared, but since that's your b squared, b is just going to be a single cos. When we factor a squared minus b squared, it would normally look like this. I hope this is coming back to you. Okay, so instead of doing a's and b's, I'm now going to write 1 plus cos x and 1 minus cos x. So essentially we factored the numerator. Then we have this in our denominator. Our denominator could be one whole bracket, and that will then cancel out with the bracket on top. And we're able to do that because we've factored the top. And we're left with 1 plus cos x, which looks like the other side, and therefore we've proven that the left side equals the right side. The next one looks kind of crazy because there's all these fractions, but we're just going to use the exact same tips that we did before. So on the left-hand side, I have 1 over 1 minus sine x minus 1 over 1 plus sine x. And on the other side, I have the 2 tan x over cos x. What I'm going to do first is, even though the right-hand side looks very simple, I want to change that tan to a sine over cos. So I got 2 times sine over cos, and all of that is over the cos x. So this is over a 1, and I'm just going to multiply. 2 sine x over cos again. Alright, I'm going to extend this. I'll probably need a little bit more room. Equals to 2 sine x over cos x, and I'm just going to split up the fraction now, divided by cos x, which is over 1, so we can flip it, and then it'll become a multiply. Now those two coses don't cancel out because they're both on the bottom, and that's going to make the 2 sine x over cos squared x. Okay, it looks pretty simple, but looking on the other side, the left-hand side, there are no coses. Why don't we change that cos squared x using the Pythagorean identity? So I'm going to write 1 minus sine squared x. And maybe I'll leave it at that because everything's a sine, just like the other side. Let's start working on the other side now. you have two fractions and they have different denominators. So in order to subtract them, you're going to have to make the same denominator. So I'm thinking probably a 1 minus sine x, 1 plus sine x denominator. And then in order to get that, I'd first have to multiply this guy, oh, I'm going to try to squish this in, by 1 plus sine x. Then I'd have to do the same to the top. Okay, and then the other one by 1 minus sine x, and then also the top. Okay, so my numerator is going to be 1 plus sine x, because once I times 1, it's just the same thing it was before, minus 1 minus sine x. Let's take off all the brackets. 1 plus sine x minus, and it's going to change the symbols in the other bracket, so negative 1 plus sine x. All over, and let's just open up these brackets too because the other side, the right hand side, doesn't have any brackets. So I'm going to do FOIL, and I'm noticing this is a difference of squares, so it's just going to be a squared minus b squared. Or if you did FOIL, some of your signs will cancel out and you'll end up with exactly what I have right now. Okay, we'll simplify the top. 1 minus 1 goes away. Sine plus sine is 2 sines over 1 squared is 1 minus sine squared x. And now we have it looking just like the other side. So we go, therefore, left side equals right side, and we feel like a genius again.